Hold on. All right. Welcome back to my channel. Hope that you liked my first video. If you have not seen the first video, you can click somewhere over here and you will be able to watch that video. And if you are new to the channel, do subscribe. That would be much appreciated. Let's get straight into the topic. This is where we left off last time, and I suggested practice and activity. I know it's been quite some days, but if you have practiced the last concepts, binary to denary conversion, if you have practiced that, I can assure you that you would have no problem solving any kind of binary to denary conversion. Moving on, we have denary to binary conversion, right? Now, this is basically the opposite of what we were doing in the previous topic. Again, if you have not seen that video, you can click somewhere and you can still watch that. Denary to binary, we will be given a denary question, a denary number, and we will have to convert that into binary. And keep in mind, the subscript or the base of denary is 10, meaning that it can contain numbers from 0 all the way up till 9. So a total of 10 digits can be represented with denary. Hence, the subscript of denary is 10. Again, denary deca. See the relation? So it's denary number system. So there are two methods for carrying out such conversions. We will go through each method one by one. The first method, as you can see on the screen, we have been given a denary number which is 142. So we have to convert it bit by bit into the binary number system. So method 1, in which we have to carry out subtractions. Let me just quickly write method 1, and our value is 142. If we recall the headings of binary, which started from 1 and went all the way up to the possible number of bits that we had. In this case, I will write the possible heading which is smaller than 142, because I cannot go beyond that in subtraction. Since I have to carry out subtractions, I will first write those headings just for reference. Let me just write the headings over here: 1, 2, 4, 8, 16, 32, 64, 128. Right. If I go beyond this, that will be 2 raised to the power 8, which means multiply 2 by itself 8 times, which is equal to 256. Now 256 is greater than 142, so we will not write that heading because we cannot subtract that from 142. So I will take my biggest possible heading, which is 128 in this case, and I will start by subtracting this heading from 142, which gives me 14. The next possible heading that can be subtracted from 14 would be 8, right? So I take 14, subtract 8 from it, which gives me 6. Now the next possible heading that can be subtracted is 4. I take 4 and subtract 8 from 6, which gives me 2. The next possible heading is 2. I take 2 and subtract from 2, which gives me 0. Now I started from the biggest or the highest possible heading, which was 128, and went all the way until I got 0. Let me quickly write the headings over here again. 8, 16, 32, 64, and 128. I will only turn the bits on which were included in the subtraction. The turning on of the bits or turning the bits on means 1, and turning the bits off means 0. So I have 128 which is involved in the subtraction. I will turn this one on. Then I have 8, then I have 4 and 2. I have turned these bits on and the remaining bits will be turned off. This is how we got this binary from our original Denary value, which was 142. That's all for this video. I hope that you will practice this conversion, because we all know that practice makes a man and a woman perfect. I'll see you with the second method in the next video.